Good morning, good afternoon, good evening, depending on when you are accessing this content. Welcome back to my YouTube channel. This morning I'll be taking you through Lab 3.1. We are going to be looking at Ethernet basics and VLAN configuration. So, a brief about this lab. Ethernet technology allows data communication over a shared media through what we call CSMA CD, carrier sense multiple access collision with collision detection. So when an Ethernet network has a large number of hosts, it brings a problem. Why? The collision domain becomes larger and it becomes a serious problem, leading to what we call broadcast storms. So this can degrade network performance or even result to a complete breakdown of the network, therefore disrupting the services. So using switches to connect LANs can mitigate collisions because it separates collision domains, but broadcast may still pose an issue. So while switches can eliminate collision domains and reduce them completely, they cannot handle the issue of broadcast storms or broadcast packets. So to alleviate broadcast storms, VLAN technology divides a physical LAN into multiple virtual local area networks so that the broadcast domains are smaller. So VLANs are used to solve that preceding problem that switches cannot solve. So hosts within a VLAN can only directly communicate with hosts in the same VLAN. Otherwise, hosts that are on different VLANs must communicate through a router. So in this lab activity, we learn how to configure VLAN on Huawei switches. So upon completion of this task, you will be able to learn how to create a VLAN, configure access, trunk, and hybrid ports, configure VLANs based on ports, configure VLANs based on MAC addresses, and also be able to view the MAC address table and VLAN information. So the scenario that we're dealing with here is a company needs to divide a layer 2 network into multiple VLANs based on the service requirement. So in addition, VLAN 10 requires a higher level of security, so only specified PCs can be added to VLAN 10. So that means we are going to be using MAC address based VLAN assignment method. So to meet this requirement, user ports of identical services on switch 1 and switch 2, so you can look at that from this topology here, can be assigned to the same VLAN. I'll read that again. To meet this requirement, user ports of identical services on S1 and S2 can be assigned to the same VLAN, and ports with specified MAC addresses on S2 can be assigned to a VLAN. Okay, so let's have a look at this. So really what we're having here, what we're having there on this particular topology is we're having S1 and S2, and it is on these switches that you're going to be creating VLANs. Then whatever you see here, R1, S3, S4, and R3, they are simply simulating end devices or access devices. So we could replace R1 with a PC, we could replace S3 with a PC, similarly S4 and R3. So I want to challenge you to in fact try it by using PCs instead of using routers and switches here. So just think of this as end devices. So there's no configuration that you're going to be doing on these devices other than assigning their individual interfaces IP addresses. So that's all we're going to be doing with these particular devices. Okay, so let's move on and do this. So the configuration roadmap, we are supposed to start by creating VLANs, then we configure port-based VLAN, then we configure MAC address-based VLAN. So to do that, step number 1, we are supposed to configure the names of the devices and disable unnecessary ports. So I've already configured the names. Disabling unnecessary ports simply means you shut down, using the shut down command, any ports or that you're not going to be using on those switches. But generally, their status is already down because we have not interconnected those ports. So we really don't have to do that. So we can begin from step number 2, which is configuring the device IP addresses. So we can configure the interface on R1, G001 with this IP. Similarly, we can do the same on R3. Then we can go on to the switches. Okay, so I already have the topology here. I already have the topology here, and I've just labeled the network addresses and the specific interface IP addresses for those particular interfaces. So let's go ahead on R1 and just do UTM. Let me clear this. Okay, so int G0/0/1. Oh, sorry, system view G0/0/1. Display this. Do we have any configuration here? Nothing. So let's configure an IP address. So IP add 10.2.1.24. Then we do the same on R3. UTM system view interface. On R3 we are connected to G002, as you can see there on the background. 02. We're supposed to give it an IP address 10.1. Sorry, .1.10.1. 24. The mask is 24 there. Okay, so after that we are supposed to configure IP addresses on S3 and S4. So S3 and S4 are also access devices in this particular scenario. They're just simulating access devices. So S3 and S4. So we want to configure these particular interfaces with IP addresses. Okay, so let's see how to do that. So to do that, of course, we need to go into the interface. Then after that, we use a command, undo port switch. This is the first time we're meeting this command. This command is used to change the working mode of the Ethernet interface from a layer 2 mode to a layer 3 mode. Thereby, after using undo port switch, then you can be able to give that particular interface an IP address. So that is for scenario number 1. Scenario number 1 is if S3 and S4 support switching from layer 2 interfaces to layer 3 interfaces. So let's try that on S3. Okay, so we go to S3 here. Then we can go into int. I'm looking at the background. Interface number is G001. Then we can use the command undo port switch. Undo port switch, like that. Then enter. So after you do that, you can do display this. What do we have? Okay, so we have undo port switch. Then we can assign it the IP address. IP address 10.1.3.1.24. So I'm looking at the background on S3. That interface is supposed to be assigned that IP. Enter. Oh, so when you do enter, we are told that the command add here is unrecognized. Simply meaning that this particular switch does not support configuration of IP addresses on that particular interface, because there's nothing wrong with this command. We know that it's correct the way it is. So then we might need then to use scenario number 2 on this particular guide. So scenario number 1 is not working for us. So let's go to scenario number 2 and have a look at that. So scenario number 2 is S3 and S4 do not support switching from layer 2 interfaces to layer 3 interfaces. So for that particular purpose, we are going to be creating what we call VLAN interfaces. We are going to be creating VLAN interfaces. A VLAN interface is a logical interface, just like a loopback interface. So we're going to learn more about that in a subsequent topic. But for now, just understand that it's a virtual interface or logical interface. So in order to be able to create a VLAN interface, you need to begin by creating the VLAN. We're going to be creating VLAN 3 on S3 and S4. Then after that, we go into those particular interfaces. We make those interfaces port link type access. We add them to VLAN 3. So that way, then after we are done with doing that, then we can be able now to create the VLAN interface like that using that command. Then we assign it an IP address. Okay, so let's do exactly that. Okay, so we are supposed to do this on both switch 3 and switch 2. So let me just get out there. Okay, so we need to start by creating VLAN 3. After creating VLAN 3, we can quit. Then we can go to interface gigabit Ethernet 0/0/1. Then we can make it port link type access. Okay. So another problem here, unrecognized command found at this particular position. Now the reason as to why we're having this as unrecognized port link type is because we switched this particular interface earlier from a layer 2 interface to a layer 3 interface. So we need to switch it back to a layer 2 interface so that we can configure the link type to be access. So to do that, we just use the command port switch. So right now, let me just display this. So you can see that we configured it to be a layer 3 interface using undo port switch. So to configure it back into a layer 2 interface, we just do that port switch like that. Okay, so if we do that and I do port question mark, you can see that now I have link type. I have now link type. So port link type access. Then port. Okay. Port default. So we want to add this to VLAN. We want to add this to VLAN 3 like that. VLAN 3. Okay. So I can quit there. Then I can come here and do the same thing. So UTM. We can go to system view, and then we can go ahead and create VLAN 3. Then quit. Then you can go into interface gigabit Ethernet 0/0/2, as you can see on the background there. Then we can do port link type. We configure it to an access. Then port default VLAN 3 like that. Okay, so once we have that, then we can create the VLAN interface. How to create the VLAN interface? You use the command interface, then VLAN if. If I do question mark here, you can see that I can be able to create the next parameter really is a number, an integer between 1 to that. So we want to create a VLAN if 3 like that. So we do that. So it gets you into that particular view for that particular VLAN interface. And now this is where you configure your IP address. So IP address 10.1.3.1 because we are on S3 here. Then 24. Okay. So after you've done that, then we can do the same here. Quit. So we can do interface VLAN if, then 3 like that. Then we can give it an IP address. So IP address 10.1.3.2.24, as you can see on the background there. Enter. Then we can quit. So now we have been able to configure the VLAN interfaces on S3 and S4. We can even decide at this particular point to test the connectivity. Before that, we can use display VLAN. So indeed, we can see that we have VLAN 3, and we've added G001 on switch 3 to VLAN 3. Okay, so let's test. Are we able to ping 10.1.3.2? Are we able to ping switch 4? Wonderful. So we are able to do it. We are able to do it. Okay. Okay. So, so now we can go to the next step. We can go to the next step. So the next step is creating the VLAN. So of course we are creating the VLANs on two switches, switch 1 and switch 2 only. So we're going to be using the VLAN batch command so that we create VLAN 2, VLAN 3, and VLAN 10 on both switches. So let's do exactly that. Step 3 is a little bit short. We are creating VLANs on S1 and S2. VLAN 2, we are creating VLAN 2, VLAN 3, and VLAN 10 on S1 and S2. So we're going to be using the VLAN batch command. So undo terminal monitor, then VLAN batch 2 to 3, then space, then 10. So we're going to create VLAN 2, VLAN 3, and VLAN 10. So enter. I need to get into system view. Good, like that. Then we do the same here. So undo terminal monitor. Then you can go into system view, then VLAN batch. Then we can also create it like this: 2 space, 3 space, then 10 space, like that. So if we do display this, not really. If we do display VLAN, we can see we have VLAN 2, VLAN 3, and VLAN 10. And of course, we have the default VLAN, which is VLAN 1. All the interfaces by default are on VLAN 1. So right now, no interface has been added to any of the VLANs we've created. So that is what we want to do in the next step here. Okay, so let's go ahead and check the next step. We want to configure port-based. On step number 4, we want to configure port-based VLANs. So we want to configure user ports on S3 and S4 as access ports and assign them to the corresponding VLANs. So of course, the ports that are going to be configured as access ports here are the ones that are connecting to the end devices. So of course, these ports here are going to be configured as access ports. These ones, access ports. Otherwise, this one here is going to be configured. We're going to be configuring that particular port and that particular port or interface as trunk ports. Otherwise, the rest we configure them as access ports. Okay, so that's exactly what you're supposed to do. So to do that, of course, you have to go into the particular interface which you want to configure. Then you configure it as either an access or trunk. Then you assign it to the VLAN that it belongs to. So that's all we are supposed to do here on both switch 1 and switch 2. Then after that, we can configure now the trunk ports. So let's begin by configuring the access ports on switch 1 and switch 2. Let's begin with the switch number 1. So create and do terminal monitor, system view. So here we want to begin by looking at or configuring interface G0/0/1 that is connecting to R1. So we want to make it an access port, link type access, then port default, VLAN 2. We can see that R1 is supposed to be on VLAN 2, so we can configure that. We can move on to the next interface just from here by typing int g0 stroke 0 stroke 13 like that. Then we can use the history command to go back to that. We configure it as an access. Then VLAN, we configure that 13 to VLAN 3, as you can see on the background there. Switch 3 is supposed to be on VLAN 3. So just like that, and we are done configuring the access interfaces on switch 1. So now we go to switch 2. Okay, so clear. So switch 2, we want to configure G0014, as you can see here on the background, and also G001. We can configure them as access, add 14 to VLAN 3, add 1 to VLAN 10. So we can just do that. So int G0 stroke 0 stroke 14. So port link type access, then port default VLAN 14 is supposed to be on VLAN 3 like that. So we can go into the next interface G001 001 like that. Then we can use the same commands. We can use the history there. Then this one is supposed to be on VLAN 10. Good. So after we're done with that, then we can now configure the trunk. We can now configure the trunk, which is G0010. So we go there, then we do interface gigabit Ethernet 0 stroke 0 stroke 10, then port link type trunk, just like that. Enter. Then port trunk allow pass VLAN. So we want to allow all the VLANs to pass through the trunk. So we're going to specify them by typing their number and then space. So we want to allow VLAN 2, VLAN 3, and VLAN 10 to pass through the trunk as tagged frames. So 3 and 10 like that. Like that. Okay. So let's do the same on S2. So on S2, we can go into interface gigabit Ethernet 0 stroke 0 stroke 10. So port link type access. Then port. Oh, sorry. This was supposed to be a trunk port, not access. So trunk. So we can just overwrite it like that. If we do display this, you can see that indeed this one is a trunk. Okay. Let me clear this. So after that, we do port trunk allow pass VLAN 2, 3, and 10 like that. So you can type that, or you can type 2 to 3, then space 10 like that. So if you do display this, you can see that indeed we have allowed these tagged packets from VLAN 2, VLAN 3, and VLAN 10 to be carried as tag packets. So that's exactly what we've done on this particular step, configuring the ports as trunk ports, the ports that is interconnecting S1 and S2. Okay, so the other thing we are supposed to do is to use the command undo port trunk allow pass VLAN command. Now, by default, VLAN 1 is allowed to pass through the trunk, But if we are not using it for security purposes, we should disable it. So the command to disable it is this one: undo port trunk allow pass VLAN 1. So let's use that on these interfaces on S1 and S2. So undo port trunk allow pass VLAN 1. Okay, so we do the same on S2 on G0010. So undo port trunk allow pass VLAN 10, VLAN 1, sorry, VLAN 1. Okay, so once we've done that, we can now go to step number 5. So on step number 5, we now want to configure a MAC address based VLANs. So what we've just done is configuring the port-based VLAN. But now we want to use the MAC address for the last device that we're having here, this R3. We want to configure MAC address based VLAN. So how to do that? So as shown in the networking diagram, R3 simulates a special service PC. Assume that the MAC address of this PC is that. We're not going to be using that. The PC is expected to connect to the network through any of these interfaces, G001, G002, and G003 on S2 and transmit data on S2 and transmit data through VLAN 10. Now, as we already know, one of the advantages of MAC address based VLANs is that if you change the device from one switch interface to another switch interface, then it should continue to work without you making any other configurations because the MAC address does not change. So that's one of the advantages of MAC address based VLANs compared to port-based VLANs, because if you move a PC from this interface, if you're using port-based, and this one was configured with a PVID of 2, and this one was configured with a PVID of 3, now if you switch a device from this interface to this interface, when you're using port-based VLAN configuration, then you'll have changed the VLAN that particular device is. But if you use MAC-based, then it remains the same. So for the interest of time, we are not going to be configuring G002 and G003. We're just going to configure G001. So to do that, we are supposed to go into VLAN 10 and use the command MAC VLAN MAC address. Then we specify the MAC address of that particular end device. So that's what we are going to begin with. So let's do that. In order to get the MAC address of the interface G002 on R3, as you can see here, in order to get that MAC address, you can use the command display int G002. So we just want to get that MAC address. So if you use this command, display interface, and then the interface name and the interface number, you'll get the hardware address. So you can just select the hardware address and copy it. Then you can now come to S2 to configure it. So clear, quit. Then we get into VLAN 10. We had already created VLAN 10. Then we can use the command MAC VLAN, then MAC address. If we do question mark here, you can see now you're supposed to specify the MAC address in this format. So we can just right click and then paste the MAC address. So that's all we need to do here to specify the MAC address of that particular interface. So the next step here should be to configure G001 as a hybrid. By the way, we had configured it on S2. G001 is the one that is connecting to R3. We had configured it as an access port, but actually we are supposed to configure it as a hybrid port. Then we also use the command port hybrid and tagged VLAN 10, so that we can allow that particular port to carry untagged frames. So the benefit of hybrid is that it can carry both tagged and untagged frames. Okay, so why do we have to configure it as a hybrid? The reason is here. So let's have a look at it. So on access and trunk ports, MAC address based VLAN assignment can be used only when the VLAN is the same as the PVID. Uh, so the PVID of the interface and the VLAN needs to be the same. So that's the main disadvantage or the reason as to why you can't use an access or trunk port when you're using MAC address based. So it is therefore recommended that you configure MAC address based VLAN assignment on a hybrid port so that you can receive also untagged packets from multiple VLANs. So otherwise, if you use access or trunk port, you can only access untagged ports from the same VLAN, but not from multiple VLANs. So that's why when you use MAC address based, then the port should be configured as a hybrid. So let's go to S2, get into that interface and make that particular configuration. So here we can quit. Then you can go into int g 0/0/1. Then after that, we can do display this so that we see what we had configured. So we had configured this to be port link type access. So we want to do port link type hybrid. So we want to change it into hybrid. Let me do this, display this. Oh, still access. Okay, so we can just undo first. Okay, so let's undo that. Undo port link type access. Okay, maybe we don't need to write that. So just undo. Renew the default configuration. Please renew the default configuration. How do you do that? Clear. Display this. Okay. Let me begin maybe then by undo port default VLAN 10. Too many parameters. Default. Okay. Question mark. VLAN. Enter. Okay. Good. So we have just disabled the VLAN first. So display this. Okay. Good. So you need to undo the VLAN. You remove it from the VLAN. The command is undo VLAN default, undo default VLAN, like that. Undo default VLAN, just like that. Then you can be able to. Let me just use undo port default VLAN. Actually, I was forgetting port. So undo port default VLAN. So that's how you delete the VLAN. So after we've done that, then we can also undo the port link type. Just port link type, enter, like that. So if we do display this, then we have nothing. We have nothing on this particular interface. Okay, so let's now make this port a hybrid port. So hybrid, enter, then port hybrid and tagged VLAN 10, like that. So that's how we configure that particular interface to carry untagged VLAN 10, and that's how we configure it to be an hybrid port. Okay, so after that we were supposed to also configure G002 and G003 to be hybrid and to carry untagged VLAN 10 frames, but we don't have to do that for the sake of time. Then the next thing is to configure the ports connecting S1 and S2 to allow packets from VLAN 10 to pass through. So we already did this. We already configured the trunk to allow pass VLAN 10 because we did 2, 3, and 10. So just the same thing, so we can skip that for now. Then we can go here, configure S2 and enable MAC address based VLAN assignments on G001, G002, and G003. So we're just going to do it on G001. So to do that, the command is mark VLAN enable. How do you use it? You go into the particular interface that you want to use MAC address based VLAN and use the command mark VLAN enable. So we're simply going to go to S2G001, then we do mark VLAN enable, enable, enter. Just like that. So that's how you enable an interface to use MAC VLAN, MAC address VLAN assignment method. After that, we can now display the configuration information. We can type display VLAN. The command is display VLAN on S1 in order to view this particular table. So let's just do that on S1, for example. Okay. So display VLAN. So if we do display VLAN, you can see that we are told that we have 4 VLANs. That is VLAN 1, VLAN 2, VLAN 3, and VLAN 10. All the other interfaces are on VLAN 1. On VLAN 2, we've added G001 that is supposed to carry untagged frames. U here means the status is up. Otherwise, D here means that G0024 is down, the status. Then we've configured on S1 G0010 to carry tagged frames because it's a trunk interface. Similarly, we've configured G0013 to carry untagged on VLAN 3 and VLAN 10 to carry tagged VLAN 3 frames. On the other hand, we've configured G0010 to carry tagged VLAN 10 frames. Okay, so that's how you use that particular table to see all the VLANs that you have. You can see also the status of your VLANs down here. Okay, so now let's go ahead and look at the next step. We can also display VLAN on S2 just to confirm whether we have all the required VLANs. So display VLAN. Okay, so indeed I think we have all the VLANs. We have VLAN 10. We've added G001 that is connecting to R3 to carry untagged VLAN 10 frames, and G0010 to carry the tagged VLAN 10 frames on S2. Okay. So you can also use the command display mark VLAN, then VLAN number, in order to display the configuration of MAC address. Displays the configuration of MAC address based VLAN assignment. So let's just do that. For example, here on S2. Okay, so display MAC VLAN 10 like that. So you should be able to see the MAC address of the interface on R3 and the VLAN it belongs to, Okay. So now let's now verify on this particular step. We want to test the connectivity and verify the VLAN configuration. So we want to ping S4 from S3 and ensure that the ping operation is successful. So S4 and S3 are on the same VLAN 3. So if we ping them, we are supposed to have a successful ping. So what we can do is we can do a data capture. For example, here, start data capture, so that we can be able to analyze those particular packets. So let me just type here ICMP so that we just look at the ICMP packets. Okay, so let me see. We want to ping. We can ping from either side. So the IP address is 10.1.3. Okay, so let me have that up. Then here we can come to S3 then we can do ping. We can do ping. Okay, so we can ping 10.1.3.2. We can ping S4. Okay, so as we see, indeed we are able to get a reply from S4. We can have a look at the ICMP packet here. Let me just double click it to open it up. So I wish earlier when I pinged S3 from S4, I would have also done a data capture, so that you see that here we have a unique header on this particular packet, and this particular header is the VLAN header here. So as you can see, we have what we call the priority field. Normally it's 3 bits, so it's 1, 2, 3. So it moves from 0 to 7. When it's 0, it simply means we don't have a priority for this particular frame, so we are forwarding it on best effort, what we call best effort. If you want to learn about the other priorities, you can look at my HCIP videos. Then we have what we call the drop eligibility indicator, DEI. Drop eligibility indicator is used to determine whether a frame can be dropped in case we have congestion on a particular interface. So when you have congestion, some frames can be dropped. If the value is 0 as it is, we can't drop it. But if the value is 1, it means you can drop it. So it's normally 1 bit. Then of course now we have the VLAN ID. VLAN ID is 12 bits. 12 bits. And for this particular example, we can see that for this frame, the ID is 3, meaning it's on VLAN 3. Okay, so I hope you've seen that. Okay, so let's look at the next step. We want to ping other devices from R1 and ensure that the ping operation fails. Why do we expect the ping operation to fail? R1 is on VLAN 2. All the other devices are on different VLANs. So we know that devices on different VLANs cannot communicate via layer 2 devices. They can only communicate via a layer 3 device. So if we ping anything from R1, we should expect that particular ping to fail. So let's, for example, ping switch 3. I need to see that. Okay, so we can ping from R1 10.1.3.1. So we should expect that to fail. Okay, Control C. Okay, let me do ping question mark negative C. Where are you here? If you want to specify the number of echo requests to be sent, you can use the negative C option. So normally that can just make your work a little bit easy. Control C to get out of that list. So negative C question mark. So you enter the number. So instead of the default, which is about 5, we just want 2. So we want to ping 10. We want to ping switch 4 10.3.2. So you're just going to do 2 requests instead of doing the 5. So it can help you save time. So the negative C option is used to do that. Okay, we can also ping 10.2. Oh, it was actually supposed to be 10.1, which is R3 there. Okay, so we should also expect it to fail anyway. So step number 3 here on the verification procedure, we are supposed to ping R1 from R3, capture packets on the link between S1 and S2, ensure that the ping operation fails. We expect it to fail, but data frames with VLAN 10 tag can be captured. So let's do that. So we go here, then we capture on G0010 there, we do data capture so that we can be able to confirm whether if we do a ping, we are going to get packets from R3. So we can now come here to R3. Let me clear this. So we want to do ping 10.1.2.1, if I'm not wrong. Yes, we want to ping R1 like that. So if we do that and we press enter, of course that will fail. And on the data capture, do we have anything? ICMP or ARP? Nothing. We only have STP packets that are being captured. Okay, so one reason, of course, as to why this is bound to fail is because if we do display IP routing table on R3, we do not have this network. We do not have 2.0. So of course, if I don't have you in my routing table as a router, I'll simply drop that packet. So for that reason, instead of pinging R1, I just want us to ping I want us to ping a destination that is from this network that is in our routing table. So 10.1.10.2, for example. So if we do that, look at the Wireshark data capture. So you can see that we are capturing some ARP packets. So let me minimize that, then open up this ARP packet, double click. So if we open up that ARP packet, indeed we can see that it has a VLAN tag, and that VLAN tag has a VLAN ID of 10. So we can see that it has a VLAN ID of 10. So that is what we wanted to verify. We wanted to really verify that when we send a packet, when we send a packet from R3, when we send a packet from R3, when it passes here on this interface, then it's going to carry the tag, the VLAN tag. Remember, on this interface G001 here, we configured MAC address based VLAN. We configured MAC address, so only this device can be able to use this particular interface, unless now we add another MAC address on VLAN 10. Otherwise, that is what we wanted to verify, and I think we've been able to see that on Wireshark. We've been able to see that indeed packets that are passing there from R3 have the VLAN tag of 10. Okay. So the last bit here is to run the display MAC address verbose. Display MAC address verbose. This particular command does not seem to work on these switches that I'm using. So let's just try it. Display MAC address verbose. Like that. Okay, good. So we actually have it. So if we do display MAC address verbose, we have the MAC address of that particular PC, and the VLAN. And the VLAN of R3, the interface on R3, and the VLAN to which it has been assigned. So that is what that will give you. All the MAC addresses and the VLANs to which they belong to. So display MAC address verbose. That command is used to do that. You can always verify your configuration from this section by using the command display current configuration. So for example, on S1 you can do display current configuration, enter. So if you do that, you can see that you've configured the system name. You can also see on the background and compare. You've configured VLAN this and this and that. So in case you run into trouble, you can always use this command to verify that on a particular interface you've configured everything you need. So you just press enter to reveal the other bits. So you can see that on G001 you've configured it as an access port and you've added it to VLAN 2. So that's how you can always verify such details. 10, you've configured it as a trunk. You've allowed pass VLAN. You have disabled VLAN 1 from passing through. You've allowed pass VLAN 2, 3, and 10, and so on and so forth. If you want to get out of this list, Control C. Control C. So that's how you do it. Control C. Okay. So otherwise, we have an exercise, a quiz on this particular lab. So please give it a try. Give this quiz a try. It's a nice one. Otherwise, thank you very much for your time. I hope you've learned something. Keep practicing. Keep practicing. VLANs are an essential part of a campus network, and you must deal with it or create them on a network. So thank you very much. Enjoy the rest of your time. Bye bye for now.